So we're doing OCR paper 5 from June 2017, and if we have a quick look at the grade boundaries, we need 82 marks for a grade 9, 66 marks for an 8, 50 for a 7, 37 for a 6, and 24 marks will get you a grade 5. 11 marks is all you need for a 4 on this paper. Question 1, we're asked to multiply two fractions together. And we might do 2 times 15 is 30 and then work out 15 times 22. But because we've got 15 as a numerator and denominator, we can simply cross-cancel those. We're effectively simplifying this calculation. And what we're left with is 2 over 22. Divide top and bottom by 2. That simplifies to 1/11. In question 2, we've got a distance time graph, and it's showing Mia's journey from her home to university. What I would always do for a distance time graph is just double check what's happening at the bottom along the time axes. I'm going to guess that these are going up in 15 minutes, so I'll just double check that. We've got 9, 9:15, 9:30, 9:45, 10. We are going up in 15-minute intervals. That would make this end time 11:30. If I just check the total distance, we've gone right up to 160 kilometres from home, and that is what's happened over the course of this journey. We're asked for average speed. Well, if we look at the entire journey, we can see we started at 0 kilometres from home. We finished at 160 kilometres from home. The distance travelled is 160 kilometres. Having a look at the time axis, we can say we started at 9 o'clock. We finished at 11:30. That is a time of 2.5 hours. We're looking for average speed, and speed is distance divided by time, which in this case is 160 divided by 2.5. I don't really want to put 2.5 into some bus-stop calculation, so I'm going to double the top and the bottom of this, and that's the same as 320 divided by 5. I might be able to work that out, but again, if I double top and double bottom, I get 640 divided by 10, which I know is 64. The average speed for the whole journey is 64 kilometres per hour. Question 3, I've got Katie who earned 16,200 and her loan repayments were 6,400. And we're looking to estimate, and she estimates that the ratio of her loan repayments to earnings is 3:8. So loan repayments comes first in the ratio. I'm going to copy these figures down. So we've got loan is 6,400. Earnings is 16,200, and what we're trying to show is that this ratio simplifies to somewhere near to this. So I'm just going to start simplifying this ratio. We can quickly swipe off the zeros, just dividing by 10 and dividing by 10 again. I've got even numbers left in this ratio, so I can divide both sides by 2, and 64 divided by 2 is 32. 162 divided by 2, well, 160 halved is 80, 2 halved is 1, so we get 81. This is looking pretty good compared to what I'm aiming for. If I just take this ratio and divide both sides by 10, I get 3.2 to 8.1, which is very close to the 3 to the 8 that we're told about in the question. So her estimate is correct. Don't lose the final mark. We're asked if she is correct. Make sure you put yes or no on a question such as that. Question 4. Rashid is investing money into an account which pays a fixed rate of compound interest each year. The value of V pounds of his investment after T years is given by this formula here. How much money did Rashid invest? If you've got this formula, this is your formula for compound interest. This here is your starting amount. So he started with £1,250. The rate of compound interest is given by this part. Now we're multiplying by 1.03. This here is 100%. Multiplying by 1 is just finding 100%. And this here is adding on 3%. 0.03 is 3 divided by 100, and that there is your 3%. That's how you turn a decimal to a fraction to a percentage. So it's a 3% increase. Part 3, circle the graph that best represents the growth of Rashid's account. Well, we know he's got some money to start with, and the money is given by V, so it has to be this one or this one. This graph is representing Rashid's money going up by the same amount each year. If you imagine these little triangles as 1 year going by, his money is going up by the same amount each time. That doesn't happen with compound interest. Okay, as you earn more money, the increase gets faster and faster and faster. So that in Rashid's, that is the best representation. Question 17, we've got some standard algebra to do. This says rearrange the equation to make x the subject. So what that's saying is we want x on its own. We're going to move everything from this side by doing inverse operations. So firstly, the opposite of taking 3 is adding 3. Do that to both sides. You end up with y plus 3 equals just the 7x. Then we've got 7x, so this is saying 7 times x. The opposite of timesing by 7 is dividing by 7. And we do that to both sides, and what you end up with is y plus 3 over 7 equals x. X is now on its own. X is the subject of the equation. Part B, factorising. We're looking for things that are common to these two terms or common factors. The only thing that is common in these two terms is the x. So I'm going to take that out as a common factor, open up some brackets, and then say x times something is x squared. X times x is x squared, and then x times something gets me back to minus xy. Well, x times y would be xy, so x times minus y is minus xy. Second bit of factorising in part 2, we've got what's known as a quadratic. Anytime you've got this x squared term, it will normally factorise into two brackets. Firstly, we will always have an x multiplied by an x to get back to x squared. And then we're looking for two numbers that add to make 8, but times to make 12. Start with the numbers that times to make 12. You've got 1 times 12, 2 times 6, and I'm going to stop there because these two numbers times to make 12, but add to make 8. So they go into my bracket, x plus 2 and x plus 6. Question 18, we've got Jenny playing 4 games of golf and her modal score is 76, her mean score is 75. When you've got unknown numbers but you know that the mean is 75, you can pretend first that they're all 75, and what that will do is tell you what they all add up to. So we've got 4 lots of 75. You can add these together. Just use a column method if you need. But 2 times 75 is 150. So these will come to 300. We're told that the modal score is 76. The modal score is just the mode. So it's saying there's more 76s than any other number. And I'll tell you now, those will usually go in the middle of this set of missing numbers. Now we're aiming for a total of 300 from these four numbers, and we know we've got at least two 76s. If we work out what this adds up to, 76 add 76, 70 add 70 is 140, 6 add 6 is 12, 140 add 12 is 152, and we're aiming for 300. From these other two numbers, we need 300, take away 52, and we're just going to work this out. I'm going to borrow from there, then we're going to borrow from there. 10 take 2 is 8, 9 take 5 is 4, and 2 take 1 is 1. So we need 148 from these two numbers. One of them must be bigger than 76, and one of them must be smaller than 76. So if we need 148, we can half this number. Half of 140 is 70. Half of 8 is 4. So we can say, well, it might be 74 and 74. But then that cancels this mode, because I can't have two 74s and two 76s. So what we'll do is take one from this and get 73 and 75. And what I'm going to do is keep working through this chain of numbers till I get a number higher than 76. And if I keep taking one from one side and adding one to the other side, I'll settle on 69 and 79. Why have I kept going? Because any of these sets of numbers, except for the 74 and 74, would have solved this problem. Well, I'm looking at the final part of the question, which says the range is 10. And range is the difference between the biggest and smallest. And here, the difference between 69 and 79 is 10. So they must be my actual final numbers. Question 19, we've got a ratio of men to children and a ratio of women to children. And we're looking for the ratio of men to women. So I'm going to track these different parts of the ratios using different colours. So we've got men is 11. We've got children is 3. In the second ratio, we've got children is 2. So I'm going to write that here. And then in the second ratio, we've got women is 5. And as long as I get the right numbers under the right labels, I am allowed to swap them around. I'm going to combine these two ratios together to form a single 3-part ratio. Now if we look at this middle zone, we've got children to be 3 parts, children to be 2 parts. If we multiply those together, we can have children being 6 parts. We just need to apply the same multiplication to the entire ratio. So here, that 3 was multiplied by 2 to get 6. I'm going to multiply this 11 by 2, and that would give me 22. On the second ratio, this 2 was multiplied by 3 to get 6. So I'm going to take this 5 and multiply by 3. 5 3s are 15. And what we've got now is a ratio that is men to children to women. I've combined these two separate ratios to create one ratio. So I'll rewrite that up here. Double check the question. We only want actually the ratio of men to women. So I want this and this, which is 22 to 15. Part B of the question, we're told that there are 36 children and we want to find the total population. I'll rewrite the ratio that we just found in part. If we're told that there are 36 children, we can see how we've gone from 6 to 36 through multiplication. We've multiplied by 6. We just need to multiply each part of this ratio by 6. 6 times 15, 6 tens are 60, 6 fives are 30, 60 add 30 is 90. On this side, 6 twos are 12, 6 20s would be 120. So we're going to need to do 120 add 12, which is 132. And quickly show that using a column method. 6 twos are 12, 6 twos are 12, add this one, it's 132. Make sure we finish the question. When it says total population, we need to do 132, add 36, add 90. Use my column addition for that. 6 add 2 is 8. 9, 10, 11, 12, 13, 14, 15. And 1 add 1 is 2. Total population is 258. Question 8, we've got a regular hexagon. That would be this one, 1, 2, 3, 4, 5, 6. And a regular pentagon. That's this, 1, 2, 3, 4, 5. And we're asked to show that angle A is 132 degrees. We'll start with the hexagon, and a calculation you can do with any regular polygon is to take 360 and divide by the number of sides. We'll find a certain angle if we do that. So I'm going to do 360 divided by 6. How many sixes in 360? I'll just use my bus stop for that. 6 into 3 is 0, remainder 3. 6 into 36 is 6. 6 into 0 is 0. So this answer is 60. If we do a similar thing for the pentagon, I'm going to do 360 divided by number of sides. I can do this using equivalent fractions. Double the top, double the bottom. We've got 720 divided by 10, which is 72. What we've found is these two angles. That is 72. And that is 60. And what we can find is this and this. Now the yellow angle on the hexagon will be 180, take away 60, which is 120. These two angles add up to 180. Similar thing for the blue angle on the pentagon. We can do 180, take away 72, which is 108. So what we've now found is this angle is 108. This angle is 120. These three angles, including A, will add up to 360. So to find A, I'm going to do 360, take away 120, take away 108. Altogether, I'm taking away 228 from 360. Which is 132. That is your angle A. Part B says Imran thinks another tile in the shape of a regular polygon will fit exactly into angle A. Is he correct? Yes or no? Well, if what Imran is saying is true, then we will be able to do 360 divided by angle A. And if that comes out at a whole number, that will be the number of sides to the shape that Imran is talking about. So let's try and work this out. 360 divided by 132. I'm going to half the top number and half the bottom number and get 180 divided by 66. Again, I can half top and half bottom, which is 90 over 33. I can divide both of these by 3. 30 over 11. And I know that 30 doesn't divide by 11 exactly. So we can say no, Imran is not correct. And just write doesn't divide exactly. If we'd have landed on something like 30 divided by 10, which is 3, then the polygon that Imran's talking about would have been a 3-sided shape. Question 9. We've got a manager of shop sampling 50 customers, and he's asking them about one style of shoe that they would buy. So these are the styles of shoe, and this is how many people said they would buy that style of shoe. George is going to buy 1,000 pairs, and he wants to know how many pairs of sandals he should buy. So we'll look at the table, we'll find sandals, and we can see that he buys, that 8 people said they would buy sandals next. So 8 out of 50 said they would buy sandals. George is going to buy 1,000 pairs. So we're going to be out of 1,000, and we want to know how many sandals out of 1,000 he should buy. We can look at these fractions and just work from one to the other using equivalents. If I times that by 2, I get out of 100. And if I then times by 10, I've got out of 1,000. So I'll do the same on the top. Times by 2, 8 times 2 is 16. And then times by 10, 16 times 10 is 160. He should buy 160 pairs of sandals. Question 10, we've got an inequality to solve. If this was an equal sign, you'd probably just say, right, I'll add 2 to both sides. So we're going to treat this exactly the same. Add 2 to both sides, trying to get x on its own. You've got 3x, negative 2 add 2 cancels. We've got the greater than sign, and 10 add 2 is 12. If you've got 3x is greater than 12, you can divide both sides by 3, the opposite of timesing by 3, and you're left with x is greater than 4. Solving an equation with x's on both sides, usually your best place to start is by getting rid of the smaller amount of x's, and negative numbers are smaller than positive numbers. So I'm going to do the opposite of taking 4x, which is to add 4x. And we do that to both sides. 6x add 4x is 10x. The plus 2 stays. The equal sign stays. And the 5 stays. I'm now going to take away 2 from both sides. And we've got 10x. That's gone. 5 take 2 is 3. And the final step would be to divide both sides by 10. X would be 3 divided by 10. You can leave your answer like that. That would be full marks. 3 divided by 10 is 0.3. So for question 11, we've got 2 vectors, A and B. And these vectors are just movements. This top number is right and left. And the bottom number is up and down. And positive numbers on the top will go right, positive numbers at the bottom will go up. On each grid below, draw a vector to represent 2 A's. Well, A is saying go 2 to the right and 1 up. So starting anywhere, I'm going to go 2 to the right and 1 up and do that once. And because I want 2 A's, 2 to the right and 1 up, do it a second time. That there that there is 2 A's. Over on this side, I'm asked to draw A plus B. Well, again, A is 2 to the right and 1 up. So I'm going to go 2 to the right and 1 up. That is A. Then I'm going to add on B, and B is 2 left and 1 up. So I'm going to carry on from where I finished, 2 left and 1 up, and this is where I finish. That is adding on B. If I remove all of these lines, then A plus B is just connecting start to finish. That is A plus B. Emma says that if she draws vector A and vector B, they will be the same. Explain why this is incorrect. Well, A, we've already seen, is 2 to the right and 1 up, so that would be something like A. And again, we've seen B is 2 to the left and 1 up. So they are the same length, but they are different directions. That's what I've written. Final part of this question says, find the value k so that k lots of a minus b equals c. Well, if we focus just on this bracket and do a minus b, we can write these vectors out. A is 2, 1. And we're going to take away b, which is minus 2, 1. And I'm just going to work out the answer to this calculation. So I've got 2, take away negative 2. That would be 4. Then I've got 1 take 1, which is 0. This is the answer to a minus b. I'm going to multiply this by something. So k, thing I'm looking for, multiplied by 4, 0, needs to come out at minus 12, 0. Multiplying vectors, whatever this number is, if we say we're going to do this times 4 and we want minus 12, then minus 12 divided by 4 will give me k. So minus 12 divided by 4 is negative 3. K must be negative 3. Does that work with the bottom numbers? Negative 3 times 0 is still 0. That's fine. K is negative 3. In question 12, we've got someone delivering parcels. She delivered 20% more parcels on Tuesday than on Monday. And then on Wednesday, she delivered 50% fewer parcels than on the Tuesday. And we've got how many parcels she actually delivered on the final day, on the Wednesday. I'm going to work this through using some diagrams. If we think about Monday as delivering 100% of her parcels. On Tuesday, she delivered 20% more parcels. So I'll do Tuesday here. So not only did she deliver the 100% of Monday, she delivered 20% more. So this would be 120%. And then on Wednesday, she delivered 50% fewer parcels than on Tuesday. So this is going to go down to a half of what it currently is. 50% of this is what we need. Well, if we've got 120% here, on Wednesday, she will have only delivered 60% of the original value. And we're told that 60%, what she delivered on Wednesday, is 72. When we know that 60% is 72, we can work out 10%. Just dividing by 6. And 72 divided by 6 is 12. So 10% is 12. We can now build up to the 100%. and that is Monday's total. That is what we're actually looking for. 100% times by 10 is 120. Question 13 says write 7 nines as a recurring decimal. That's literally saying work out what 7 divided by 9 is. So we're going to see how many 9s go into 7. 9s into 7 is 0, so we're going to need a decimal and some extra digits to work with. 9s into 7 is 0, remainder 7. And then we can do 9s into 70, which is 7. 7 9s are 63, remainder 7. Again, 9s into 70, 7 remainder 7. We can see there's our recurring decimal. We get 0.7 recurring. Part B, Sally divided a 2-digit number by another 2-digit number and got 3.1818, etc. That is telling you to turn this recurring decimal back into a fraction. So we're going to use algebra to do that. We can say x equals the recurring decimal that we've been given. We will work out what 10x's are, and all that happens is these digits move one place to the left. So we get 31.8181. Keep going with this, find 100x, and again the digits just move to the left. We get 318.1818, and what I'm looking for is this 0.1818, 0.1818. I want this repeating pattern to match after the decimal point. So I'm going to use these two parts of my algebra and do 100x, this, take away x, which is this, and that's going to give me 318.1818, take away 3.1818. What happens when we do this? Well, 8 take 8 is 0, 1 take 1 is 0, etc, etc. You can left with 318 take 3, which is 315. And we know that we got this answer from 100x, take away x, which is 99x. 99x is 315. If we've got an equation that says that, then 1x would be 315 divided by 99. Now we're nearly there, but this is not the right answer because we're looking for a 2-digit number divided by another 2-digit number. So we've got to simplify this fraction as much as we can to get until we've got two 2-digit numbers. If we divide top and bottom by 3, I get 105 over 33. And then again, dividing top and bottom by 3, I get 35 over 11. Just dividing top and bottom by 3. So these are now two 2-digit numbers. They are 35 and 11. Question 10. John's got 8 different shirts, 6 different hats, and 4 different scarves. And he's picking a shirt, a hat, and a scarf. And we want to show that there are 192 different combinations. If you're trying to work out how many combinations, you just multiply those 3 numbers together. 8 times 6 is 48, and 48 times 4 will be the 192. That's all you need to write for that mark. John thinks that if he picks just 2 of the 3 items of clothing, there will be more than 192. Well, let's work out how many combinations there are by picking 2. By picking 2 items of clothing. If we look at shirts and hats, we will do 8 times 6. If we're looking at shirts and scarves, we'll do 8 times 4. And if we're doing hats and scarves, we will do 6 times 4. That is how many combinations there will be from picking just 2 items. 8 times 6 is 48. 8 times 4 is 32. 8 times 4 is 32, and 6 times 4 is 24. 48, add 32, add 24, comes to 104. That is how many combinations there are for just 2 items. We're asked to show it's more than 92. He is wrong. Question 15 is simplifying surds. We should know that root 50 can be broken down into root 25 times root 2, just because 2 25s are 50. Why would we do this? Well, we know the square root of 25 is 5. So root 50 is actually 5 root 2's. And we're going to add on another root 2. 5 root 2's, add another root 2 is 6 root 2's. Part 2, we've got a fraction with a surd as its denominator. We never really want this, and there is a way to get rid of this. If we multiply top and bottom of the fraction by root 6, you'll see what happens. 10 times root 6 is 10 root 6. And root 6 times root 6 is root 36, which is actually 6. We've now got 10/6 in this fraction, and 10/6 will simplify to 5/3, just halving the top, halving the bottom. So you end up with 5 root 6 over 3. Part B, we've got a calculation where we know that there's been an error, and we're actually looking at 64 to the minus 2/3. We'll work this through. The first step that we're being told, find the cube root of 64, then multiply by 2. Well, this here is finding the cube root. This 3 is cube root. So I am going to find the cube root of 64, which is 4. 4 times 4 is 16, times 4 again is 64. So that bit is done. This 2 is not multiplying by 2. This 2 is squaring. So we need to do next 4 squared, which is 4 times 4, which is 16. That there is an incorrect step. We've actually taken care of that as well. Final line, it says the negative power makes the answer negative, so the answer is -8. Well, we've dealt with this cube rooting. We have dealt with this squaring as well. This negative power is all we need to work with. Negative power will not turn this negative. 16 raised to a negative power will put 1 over that number. Finds the reciprocal. So the correct value is actually 1/16. Question 16, we've got circle theorems, and we're asked for angle X, which will always be twice this angle here. So I'm going to double 52 and get 104. And the reason being, angle at the centre is twice the angle at the circumference. We're also asked for angle Y. And if we look at these two angles together, they will always add up to 180. So Y is going to be 180, take 52, which is 128. And the reason is opposite angles on a cyclic quadrilateral add to 180. Question 17, and we're getting into the meaty algebra now. We've got two quadratics. The top one is the difference of two squares. We've got a square number, and the difference is the subtraction between them. That will factorise into two brackets. X and X is going to get me the x squared term, and we just need to know the square root of 16 is 4. In one bracket you'll have +4, and in the other bracket you'll have -4. If you re-expand those brackets, I promise you it will land on x squared minus 16. Bottom quadratic is a little bit more standard. We're looking for two numbers that add to -3 and multiply to -4. So let's start with the numbers that multiply to -4. We've got 1 times -4. I'm going to stop right there because these two numbers, 1 and -4, will add to -3. So they're my two numbers that are going to help me factorise that quadratic. Double brackets again, x in both brackets, and these numbers I just found, +1 take 4 is my quadratic factorised. We're happy because we've got a matching bracket top and bottom, meaning we can just cancel that and we're left with x plus 4 over x plus 1. Part B, we've got a triple bracket and we're basically being told to expand it. This is the expanded version of this triple bracket. So I'm going to look at the first two brackets, use a grid method. And if we just multiply each terms together, x times x is x squared, x times 3 is 3x, minus 4 times x is minus 4x, and minus 4 times 3 is minus 12. These here will simplify. Minus 4x plus 3x is minus 1x. Just taking these terms across here, we've got the x squared minus x and the minus 12. And what I'm going to do is multiply that by the third bracket, which is x plus 5. X times x squared is x cubed. X times negative x is negative x squared. X times negative 12 is negative 12x. 5 times x squared is 5x squared. 5 times negative x is negative 5x. And 5 times negative 12 is negative 60. In my original question, I'm just looking for A and B. Well, B is this number that sits on its own. So that one is just negative 60. And A is the thing before x squared. And I've just seen I made a mistake. That should have been plus 5x squared. 5 times x squared is plus 5x squared. So I want my x squared terms. 5x squared take x squared is 4x squared. A, the thing before x squared, will be 4. Question 18, I've got 120 adults. We know that 85 watch football, 78 play a sport, and 20 do neither. Already I'm thinking, well, 85 add 78 add 20 is too many people because I've only got 120 people. 85 add 78 will be more than 120. So I've got too many people. I'm going to add these numbers together. So I've got 85 watching football. Added to that to those who play a sport. And those that do neither. 5 add 8 is 13. 8, 9, 10, 11. That would be 18. I've got 183 people, which is 63 too many. These 63 extra people must be people that do both things. They watch football and play a sport. And what that's making me think about is a Venn diagram. Got football. I've got sport or play a sport. And I should include the outside as well, so we should have a rectangle around this. We've already seen that I've got 63 people too many and said that these 63 people will be the people that do both. So they're going to sit in the middle of my Venn diagram. We know that 85 people watch football, so this entire zone here has to come to 85. I've already got 63 in that circle. I want 85, so I need 22. just watching football. That together is 85 in total watching football. I've got 78 people playing a sport, so all of this needs to come to 78. I've got 63 of them there. This part must be 15. 15 and 63 is the 78. Don't forget the 20 people that do neither. I can quickly check that these numbers add up to 120. 22 add 63 is 85. Add 15 would be 100, and add the 20 is 120. We've now got a diagram that can help us answer the question, which is an adult chosen at random from those who watch football does not play a sport. Well, all of these watch football, so it's going to be out of 85. I'm choosing from those who watch football, and I want the people that don't play a sport. That's these 22 people here. It doesn't say simplify my answer, so I'm not going to bother. Question 19, we've got a quadratic equation in completed square form. And what this leads to is what's called the turning point of the graph. A quadratic will always produce a U-shaped curve, and we can get a coordinate out of this completed square form if we just open some brackets. The -2 I'm going to change to a +2, and I'm going to keep this -3. That there is the coordinates of the turning point. So we just need to mark this on the graph. We're going to go across to 2 and down to 3. And that is my turning point, 2, -3. Part B, we've got another quadratic that's been sketched. And we've got here is 2 special points on the curve called the roots of the equation. And what we can do is put these into a set of double brackets. So we're going to have x and x. We're going to actually reverse the signs of these and get +3 and +1. And if I expand this double bracket, I will turn it into this expanded form. So I'm going to do that now. X times x is x squared. X times 1 is 1x. 3 times x is 3x. And 3 times 1 is 3. Simplify these middle two terms. We get x squared plus 4x plus 3. Now, not quite finished, because this is also a key point on his graph, and this 12 is the C. And at minute, we've got our final number to be 3. So how do I turn this 3 into 12? I'm going to multiply everything by 4. And what we get is 4x squared plus 16x plus 12. We've got A equals 4, B equals 16, and C equals 12. So final question on this paper, we've got a 4-sided shape made from 2 triangles. All this is just information on the diagram, and we're told the land is sold for 10 million per square kilometre. That there is suggesting that this is an area problem. If you've ever got 2 triangles connected, 9 times out of 10, you will need to find this side connecting them. So I'm going to do that using this right-angled triangle, where the base is 5, the height is 12, and this is the line connecting the triangles. This is a Pythagoras' theorem question. So we've got a squared plus b squared equals c squared. A is 5, b is 12, and c is what we're looking for. And if 169 equals c squared, then c will be the square root of 169, which is 13. 13 13 is 169. Since this is an area question, I may as well work out the area of this triangle, which is going to be base times height divided by 2, which is 60 over 2, which is 30 square kilometres. We just now need to work out the area of this triangle, which is not right angled, so we can't just use base times height over 2. But what we have got is this is 3. This is 13 from this part of the question, and this angle is 30. We can use area equals half AB sine C, where A and B are these two sides. So I'm going to do a half of 3 times 13 times the sine of the angle between them. And I'm going to need to work this out without a calculator. Well, 3 times 13 is 39. This is going to be a half times 39 times sine 30 is actually a half as well. So we've got a half times 39, which is a quarter of 39. And a quarter of 39, well, 39 halved, 19.5. 19.5 halved is going to be 9.75. So we know this area is 9.75 kilometers squared. Total area is 30 plus 9.75, which is 39.75. And we need to answer the actual question, which says if this land is sold for 10 million per square kilometre, then we're just going to multiply this area by 10 million. 10 million is a 1 with 6 zeros on it. For every one of these zeros, this decimal point is going to move 1 to the right. So 39.75 times 10 million will be 39. This is times 10 once, twice, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is your final answer. So I lied when I said final question was the previous one. We've actually got one more to do. Part A of question 21 says explain why 2n plus 1 is an odd number. Well, 2n is even. That's a mathematical way of saying the 2 times table. And then if you're going to take an even number and add 1, you'll get an odd number. This next part says prove the difference between the squares of 2 consecutive odd numbers is a multiple of 8. Well, we've got one odd number already, 2n plus 1. Consecutive means the next one, and difference is a subtraction. So the next odd number will be 2n plus 3. From one odd number to another, we add 2. From 1 to 3 is add 2. From 3 to 5 is add 2. So this is a difference here between odd numbers of 2. This difference in the question is a subtraction. And don't forget the bit that says the squares of consecutive odd numbers. So this is the algebra from the question. We now need to just work this out. What we've got is two sets of double brackets to expand. And if you expand these, you get and I've simplified as I've expanded. I've left this second one in a bracket because I've got to take away all of this. So we end up with 4n squared plus 4n plus 1. Take away 4n squared. Take away 12n. And take away 9. I'm taking away all of that bracket. We can now tidy this up. 4n squared take 4n squared is gone. 4n take 12n will be negative 8n. And 1 take 9 will be negative 8. What I can do with this is take out a factor of 8. Open up some brackets. 8 times something is minus 8n. 8 times minus n is minus 8n. And 8 times something is minus 8. 8 times minus 1 is minus 8. What we've got is something in a bracket being multiplied by 8. That there is showing you've got a multiple of 8. Heavy algebra, that one. Hope you enjoy this paper, guys. Go back to the start, see what marks you got, see what grade that comes to.